Hello everyone, welcome to this data science video on fundamentals of NLP. With NLP becoming so popular, its applications are adding value to various organizations. In this video, we'll have a look at the different types of NLP, how it is used to create methods like TF-IDF, how text data is cleaned, how you can break it down into specialized NLP analysis, how predictive analytics is used, how text is converted to a numerical feature, and of course, the role of AI in all this through automated NLP process. Let's get started. Overall, NLP has to do with making sense with humanly readable text. Because of the use of AI in it, it is often considered as purely AI methodology. Even though certain NLP methods are purely stats, mainly because AI sells more, making everyone forget the humble beginning of NLP. Nevertheless, NLP is very useful today as large part of our data is text-based, especially natural language text. Under this umbrella, we include social media text. Although it is not grammatically correct, it is humanly readable. It is useful to understand that NLP doesn't work in vacuum. It uses other parts of data science like supervised and unsupervised learning. Although there are certain techniques specially developed for NLP, we'll look at them later on. Even those techniques are not always accurate. There is a lot of, but they still add a lot of value to it. They can help us understand more about different documents and even organize them. Finally, we have to study NLP since this is the part of the data science that is less likely to be fully automated. So what is NLP exactly? If we take an NLP pipeline, it is a specialized process in which it takes text as input, converts them into numeric data, and bring about the insight into that. Oftentimes, it can predict sentiment polarity. Also, NLP can help us understand what kind of topic a corpus or document has, shedding light on the complex relationship of words and patterns. This is why it is closely related to NLU, which we term it as natural language understanding. All these made possible due to interdisciplinary fields like stats, machine learning, and AI. If someone tries to simplify that NLP is one or two things, probably they haven't grasped the bigger picture. In NLP, data engineering is particularly important due to the fact that the text seems to be particularly noisy. Of course, data engineering is important in other data science methods too, but you can get away with it in certain methods like time series analysis, since the nature of the data is quite different. In NLP though, you cannot do much without good data engineering. Also, some specialized AI tools can automate some parts of the NLP to make things a bit more easy. Let's now look at the various aspects of NLP, breaking down into different groups and subgroups. For starters, we can organize the methods into basic ones and advanced ones. It is an arbitrary distinction, by the way. Advanced methods will make more sense once you have done some preliminary analysis using the basic methods. Regarding the basic methods of NLP, this includes things like basic frequency of the terms, but in advanced form, they'll be represented as frequency-based heuristics. One such heuristic is TF-IDF. Basic methods of NLP also include data cleaning process. Finally, POS analysis is also qualifies under the basic method, although some people may consider it as advanced, since it has an auxiliary role in NLP, as their output is not there that insightful nor that wrong, unlike the output of advanced NLP methods. Since methods include stats, machine learning, and predictive, such methods include stats, machine learning, and predictive analytics. Things like naive-Bayes classifier, Bayesian analysis are ideal for this sort of work. Feature engineering is also a key in advanced NLP methods, since without it you cannot run most of their advanced NLP method. Also, feature engineering itself can be insightful as well. One such example is word to vector. Perhaps the most advanced method of NLP is the AI system, particularly the specialized ones like CNNs and RNNs. I mentioned term frequencies earlier but didn't clarify what these are. For starters, terms are small piece of text that are particularly inherent to us. Usually, these are words or phrases, but other things like numbers and abbreviations can also qualify as terms. As for the frequency, this is how many times a term appears. Oftentimes, these are expressed to a proportion of total number of terms in the document. TF-IDF is a very interesting option of all of these. Its usefulness makes it most useful method in NLP. It stands for term frequency inverse document frequency. It is a product of term frequency and inverse document frequency. As for the second one, which is the inverse document frequency, it's more of a stabilizing factor. We can say TF-IDF as a regularized frequency matrix. Usually TF-IDF values are 0.4 or more. It is important to understand that no method can capture the whole signal of the text, which is why frequency-based methods generally play an auxiliary role in the NLP. Besides, oftentimes the meaning that we are trying to explain is the piece of text goes beyond the terms, which requires other methods that explain the combination of terms. This kind of approach is under the umbrella of n-grams. However, frequency-based methods are more inexpensive in terms of both computation and storage. N-grams can be very expensive to grade especially for a large data set. Let's now take a close look at TF-IDF metrics. This metric requires a set of documents, or also known as corpus. A document can be a single paragraph to a whole book. As long as it has some consistency to it, it qualifies. Also, all documents should have some similar vocabulary. In other terms, a large overlap among those vocabularies. Term frequency is a normalized value of the expressed normalized values of the term expressed with the value between 0 and 1. This is easy to calculate and quite straightforward. However, it doesn't point the full picture when it comes to how important the term is. To obtain the more holistic view of this, we use the inverse document frequency, which is a natural logarithm of the ratio of total number of documents in the corpus over the number of documents having the term in them. Sometimes we add 1 to the denominator so that it always yields a real number. The main advantage of TF-IDF is that it can safeguard us against the terms that are too frequent or too rare. Too frequent terms are usually stopwords. They add little to no value to the NLP project. In fact, some packages have the option of removing it altogether even before you start evaluating the terms. High TF-IDF values are generally good. Also, terms that have TF-IDF value less than 0.05 are often omitted in the model. Besides that, make weak features and takes up the memory space and CPU time when we analyze. What about the fact that text data is noisy and they need cleaning before they are used? There is no doubt that this is an essential part of every NLP project. Even those data set that have clean text should follow the process of cleaning up. Cleaning up involves getting rid of some special terms. This includes stopwords mentioned previously, as well as certain irregular terms such as people, name, dates, special characters, etc. Stopwords are usually antonyms, comma words. How well the text is clean explains the difference between the experienced practitioner from a newcomer. The former will take it quite seriously, while the latter will do just the basic of it or avoid altogether. Although it is not a rocket science, it does not take a lot, but it does take a lot of time in order to perform it thoroughly. Depending on the dataset, you may introduce several iterations of cleaning. As you may have guessed, cleaning up the text improves the performance of the model. It may even save up some computational space. What's more, in fact, the whole cleaning process can be in fact the whole cleaning process can be automated. It is recommended that you start with that. Let's look at parts of speech. Parts of speech is an important piece in base NLP method and is an integral part of NLU. Parts of speech involves nouns, verbs, adjectives, prepositions, and other parts of natural language text. In some language, including English, it is not simple to time out which is which. Sometimes make sometimes makes PO parts of analysis and parts of speech analysis a challenging task. Even though we don't relate, we do the same thing subconsciously. We when reading an article or listening to someone when they talk. Parts of speech analysis is very useful for NLU as well as mining terms of interest in a piece of text. However, it is not essential for majority of NLP model. POS analysis seems like a great tool, but it is not accurate either. Most Python packages has a POS tracking function that performs the test, and the result are often even for the language such as English, they are not accurate. Most POC packages out there uses conventional machine learning model to perform the task. Also note that the POS analysis is different from language to language. Predictive analytics using NLP. Let's now take a look at the how predictive analytics systems are used in NLP. These systems are very much like conventional predictive analytics, but they use the text data on input and sometimes they output text data also. In many cases, they need the text data to be converted into numeric function. Since not all the models work on the text directly, predictive analytics systems in the NLP are mostly stats based, but there are several machine learning and AI options too. Naturally, the stats-based systems treat the frequencies on as probabilities, which is why the most more the text we have, better the system works. These probabilities are more accurate. Stats model include knife base, glove, several others, and several other systems. Any predictive system in NLP has a lot of benefit from good text-based features. This can either be the values of TF-IDF metric or any custom feature from advanced methods. Also, we should note that some systems use graph to analyze the relationship between the key terms. Normally, before starting the analysis, analyzing such tools, we need to know the basis of graph theory and how to turn the data set into a meaningful graph. Finally, NLP systems tend to require a lot of data as they have a greater risk to overfitting. This is mainly because there are many features involved even after removing the less important feature. Let's look at text featureization. Often, many of these systems require some numeric input, which capture the signal of the text data. This transformation is made possible through a feature called text featureization. This involves turning text into number, which can be utilized in the predictive analytics models. Naturally, just the conventional numeric metrics, these features has to be cleaned up and normalized before they are fed into the model. Featureization process, however, is usually done in an automated way, be it through application of TF-IDF or through other methods. It doesn't require you to have a close attention. They not just capture the important terms, but also the relationship between the terms. This is particularly important when we want to pinpoint certain signals that may not be captured when we try to just capture the terms. Fortunately, there are several methods that are there to create features out of these texts. Apart from the glove and TF-IDF, there is word to vector, which is one of the most popular option, even if it is a big demanding on the resource. Occasionally, there are n-grams which are taken into account when we want to group the terms, which are usually in a consecutive way. Also noting stop, also noting that stopwords is one of the process where we remove the stopwords. In many cases, the custom-made features are uh, quite powerful in terms of predictive value. The problem with the whole featureization process is that features created as many are many, and some of them can be highly correlated. That's why feature selections and other dimensional reduction methods are strongly recommended as the next step of featureization process. Besides, pure feature means less computational resources oftentimes perform better. Automated NLP system. NLP process is a time consuming, which is why certain NLP processes have come about the way they can be automated, and they are becoming increasingly popular. As the AI systems evolve, there are many specialized AI systems that concentrate on the NLP task. They require numeric feature, but not too many of them. Fine-tuning these methods is not a straightforward method as the case in their basic counterparts such as naive Bayes. Automated NLP methods can be supervised or unsupervised. Among the first category is the recurrent neural network, such as LSTM, as well as convolutional neural networks. Nevertheless, you can always use multi-level perceptrons if you prefer, though it is not as common as LSTM or convolutional neural networks. All these methods are under the umbrella of deep learning. They are commonly used for various applications. As far as supervised systems, there are topic extraction models and autoencoders. They basically perform clustering on documents to figure out which of them are more similar, which also provides the most important aspects of the group, such as which term stands out. Autoencoders are a specialized type of deep learning that provides a better representation of the information in the feature. All these methods are great at spreading the NLP significantly, but they often require specialized know-how. Apart from these methods in the data science, and we trying to start from the ground level, we can always look at the machine learning offerings from Google as well as in Amazon. They have the natural language processing offering where they find out the entity, sentiments, and the keywords. If we don't want to depend on the corpus that we have. Yeah, that's it for today. These are the basic of the NLP.